You have already died, multiple times. You do not remember, because the version of you that died is not listening this. When quantum mechanics is taken to its logical extreme, one conclusion is inescapable. From your perspective, death is impossible. You will survive every accident, every illness, every catastrophe, because consciousness only continues in branches where you remain alive. This is not philosophy. This is quantum immortality, a direct consequence of the many worlds interpretation proposed in 1957. Outside observers will watch you die, but you never will. You will keep waking up, confused, wondering why the gun jammed, why the cancer vanished, why you are still here when the odds said you should not be. If you are ready to follow quantum mechanics into its most disturbing prediction, hit that like button and subscribe. Prepare yourselves. We begin. Imagine a machine, simple construction, a quantum particle detector wired to a gun aimed at your head. The detector watches a single radioactive atom. When the atom decays, the gun fires. When it does not decay, nothing happens. 50-50 probability, pure quantum randomness. You sit in the chair, you press the button, the detector measures the atom. From outside the room, an observer watches. They see one of two outcomes. The atom decays, the gun fires, you die instantly. Or the atom does not decay, the gun stays silent, you live. 50% chance either way, standard probability. Run this experiment with 100 people, roughly 50 survive, 50 do not. The math is clean, the outcome is random, nothing controversial so far, but now consider your perspective. You press the button, the detector measures. In standard quantum mechanics, the wave function collapses. One outcome becomes real, the other disappears. But the many worlds interpretation says something different. The universe splits. Both outcomes happen. In one branch, the atom decays, the gun fires, your body slumps in the chair, brain destroyed, consciousness terminated in that branch. In the other branch, open your eyes, you're alive, you experience relief. Here is the critical point. Your consciousness only continues in the branch where you survive. The branch where you died contains your corpse, but no experience, no awareness, no you to observe the outcome. From your subjective perspective, you only ever experienced the survival branch. You pressed the button, nothing happened, you lived. Press the button again, same setup, 50-50 odds, the universe splits again, one branch, death, one branch, survival. You only experienced the survival branch, again and again. Press the button 10 times. An outside observer watching 10 people perform this experiment sees a predictable distribution. After 10 presses, most participants are dead. Maybe one person survives all 10 by sheer luck, 1 in 1,024 chance. But you're not watching from outside, you're inside the experiment. You press the button 10 times. 10 times, you survive. Not because you are lucky, because there exists a branch where all 10 atoms fail to decay at the moment of measurement, and your consciousness only continues along that branch. The other branches contain your corpse after press 1, press 2, press 3. You never experience those. You cannot experience those. Experience requires consciousness. Consciousness requires being alive. This is quantum suicide, the thought experiment that breaks death. You are locked into a survival bias enforced by physics itself. Every quantum event that could kill you creates a branch where it does, and a branch where it does not. You only ever find yourself in the branch where it does not. Always, without exception. Because the alternative is not experience, it is nothing. The machine does not care about you. The atom decays or does not decay according to quantum probability. The gun fires or stays silent according to deterministic wiring. The universe splits according to the mathematics of quantum mechanics. But your subjective experience threads through only the branches where you remain alive to have experiences. You become a survivor by necessity, not by choice. Not by luck, by the structure of reality itself. Now make it worse. Replace the machine with life. Every second, trillions of quantum events occur in your body. Particles decay, molecules interact, electrons tunnel through barriers. Each event is a branching point. Most branches continue normally. Some branches contain catastrophic failures. A cosmic ray strikes a neuron in your brainstem at exactly the wrong moment, triggering a fatal seizure. A quantum fluctuation causes a critical protein to misfold, initiating runaway cell death. A particle interaction spawns a mutation that becomes aggressive cancer. These branches exist. You died in them. But you are not reading this in those branches. You're reading this in a branch where every quantum event in your body, for every second of your life, happened to avoid killing you. Trillions of rolls of quantum dice all came up survival, not because the dice are loaded, because you only exist to notice the outcome in branches where they did. The thought experiment strips away the comfortable fiction that death is something you will experience. It is not. It is something that happens to you in other branches, other versions. You will never meet them. You will never know they existed. You will just keep waking up day after day in the branch where you are still alive. The gun jammed. The cancer went into remission. The car swerved at the last second. Every time, forever. From the outside, this is absurd. People die. We see it happen. We bury bodies. We grieve. But quantum immortality does not deny that death happens. It denies that you experience it happening to you. Your consciousness is a thread running through the multiverse, touching only the branches where you survive. The thread never ends. It just keeps going, branching, surviving, continuing, because the alternative is not an experience you can have. This is not a comforting thought. This is physics taken seriously, followed to its conclusion, and the conclusion is that you are trapped, not in a single timeline, but in an infinite set of timelines, all of which share one property. You are alive in them. You cannot escape into death. You can only continue into the next moment where you are still here, still conscious, still experiencing, still unable to experience anything else. We understood the mechanism, but we have not yet addressed the foundation. Why does the universe split at all? The answer lies in the interpretation of quantum mechanics that most physicists tried to ignore for decades. Quantum mechanics has a problem, a measurement problem. When you measure a quantum particle, you get a definite result. The particle is here, not there, spin up, not spin down, decayed, not intact. But before measurement, the particle exists in superposition. It is in multiple states simultaneously, described by a wave function that gives probabilities for each possible outcome. The math works perfectly. The predictions match experiments to absurd precision. But the question remains, what happens during measurement? How does superposition become a single outcome? The standard answer, called the Copenhagen interpretation, says the wave function collapses. Measurement forces the quantum system to pick one outcome. The other possibilities disappear. They stop being real. This interpretation was crafted in the 1920s and became the default view taught in every physics course. It works for practical purposes, calculate probabilities, perform experiments, collect results. Do not ask what collapse means physically. Do not ask what counts as a measurement. Do not ask where the other outcomes go. In 1957, a graduate student named Hugh Everett proposed something different. What if the wave function never collapses? What if all outcomes happen? When you measure a particle, the universe splits. One branch contains the particle here. Another branch contains the particle there. Both branches are real. Both continue existing. The observer splits too. One copy sees outcome A. Another copy sees outcome B. Each copy experiences a definite result, but both results occur. This is the many worlds interpretation. It sounds insane. It implies the universe is constantly branching into countless copies. Every quantum event, every measurement, every interaction that depends on quantum randomness creates new branches. The number of branches grows exponentially. After 1 second, the universe has split more times than there are atoms in the observable cosmos. The extravagance seems absurd, but Everett pointed out something crucial. Many worlds is simpler than Copenhagen. It requires fewer assumptions. You do not need wave function collapse. You do not need a special rule for measurement. You do not need to define what counts as an observer. You just follow the math. The Schrödinger equation, which describes how quantum systems evolve, never includes collapse. It is deterministic. It is continuous. It produces superposition naturally. Copenhagen adds collapse by hand, inserting an extra process not present in the fundamental equations. Many worlds removes that addition. It takes the math seriously and follows where it leads. Consider Schrödinger's cat, the famous thought experiment. A cat in a box, a vial of poison, a radioactive atom. If the atom decays, the vial breaks, the poison releases, the cat dies. If the atom does not decay, the cat lives. Close the box. Wait 1 hour. The atom's wave function is in superposition, decayed and not decayed. According to quantum mechanics, the cat is also in superposition, dead and alive. Open the box. You see one outcome, dead cat or alive cat. Copenhagen says the wave function collapsed when you opened the box, or when the atom interacted with the detector, or at some undefined moment. One outcome became real, the other vanished. Many Worlds says both outcomes are real. When the atom reaches the point of decay or not, the universe splits. One branch contains a decayed atom and a dead cat. The other branch contains an intact atom and a living cat. When you open the box, you split too. One copy of you sees the dead cat. That copy exists in the dead cat branch. Another copy of you sees the living cat. That copy exists in the living cat branch. Both are real. Both continue. Neither is more fundamental than the other. This resolves the measurement problem by denying it exists. There is no collapse. There is no moment when one outcome becomes real and others disappear. There is only branching. The wave function describes all branches simultaneously. Observers are part of the wave function. When an observer becomes entangled with a quantum system through measurement, the observer enters superposition too. You and the system branch together. Most physicists rejected this in 1957. Too radical, too extravagant, too difficult to accept that every possibility actually happens. Everett's advisor, John Wheeler, supported the work initially, but distanced himself later under pressure from colleagues. Everett left academic physics. He worked in defense research, operations analysis, game theory. He never returned to quantum mechanics professionally. The many worlds interpretation was ignored for years, but the interpretation never went away. It kept resurfacing because it solves problems that Copenhagen leaves unanswered. In the 1970s and 80s, physicists like Bryce DeWitt and David Deutsch revived and refined the idea. They showed that many worlds is not just philosophically coherent, but mathematically rigorous. It follows directly from taking quantum mechanics at face value without adding extra postulates. Today, surveys of physicists show many worlds has significant support, not a majority but a substantial minority. Some accept it because it is the simplest interpretation, others because it makes certain quantum phenomena, like quantum computing, easier to understand. Quantum computers exploit superposition to perform calculations on all possible inputs simultaneously. In many worlds, this is literal. The computer branches into versions processing different inputs in parallel. The final measurement selects one branch, but the computation happened across all branches. The core claim is straightforward. Every quantum event with multiple possible outcomes produces a branching. A photon hits a half-silvered mirror. 50% probability it reflects, 50% it transmits. In many worlds, both happen. The universe splits into a branch where the photon reflected and a branch where it transmitted. An electron in your retina absorbs or does not absorb a photon from a distant star. Both outcomes occur in different branches. A particle in your brain tunnels through a barrier or does not. Both happen. You split. One version experiences the tunneling. Another version experiences the barrier holding. This happens constantly. Quantum events occur trillions of times per second in every cubic centimetre of space. Each event is a potential branching point. Not all cause significant macroscopic differences. Most branches are nearly identical, differing only in the position of a single particle deep inside a rock. But some branches diverge dramatically. The particle that did or did not trigger a neuron firing. The cosmic ray that did or did not cause a mutation. The quantum fluctuation that did or did not destabilize a star. The branching structure creates a vast tree of possibilities. Every moment the tree grows, new branches emerge, existing branches continue, no branches merge or disappear. Once split, branches are separate. They cannot communicate, they cannot interact. An observer in one branch has no access to other branches. You experience one thread through the tree, one continuous path from the past to the present, but countless other threads exist, containing other versions of you experiencing different outcomes. Many Worlds makes a bold claim. This is not speculation. This is what quantum mechanics actually describes if you do not artificially truncate it with collapse. The math produces branching. The equations generate superposition. Observers are quantum systems too, subject to the same rules. Therefore observers branch. Therefore all outcomes are real. Accepting this means accepting that you are not unique. There are other versions of you in other branches, versions that made different choices, experienced different outcomes, observe different measurement results. These versions are just as real as you. They think they are the only version, just as you do. They experience consciousness, continuity, selfhood. But they exist in branches you cannot access, and this is where quantum immortality emerges. If all outcomes happen, then outcomes where you survive happen, always. In every situation where death is possible but not certain, there exists a branch where you survive. Your consciousness continues in that branch. The branches where you died contain your corpse but not your experience. You thread through the branching structure along the path of continued consciousness. You are immortal not because death does not happen, but because you only experience the branches where it does not. But the foundation has cracks. Many worlds explains what happens. It does not fully explain what you experience, and that gap is where the theory starts to break. Consciousness is the hole in the theory. Many worlds explains branching. It explains why all outcomes occur, but it struggles to explain why you experience one outcome and not others. When the universe splits, both branches are real. Both contain versions of you. Both versions are conscious. Both experience continuity from the moment before the split. So why does it feel like you experience only one outcome? This is the binding problem of quantum immortality. If you split into two versions at every quantum branch, what determines which version is you? The answer most physicists avoid. Both are you. There is no privileged branch, no original versus copy. Each version has equal claim to being the continuation of your consciousness. They diverge from a common past, but both are equally real futures. But subjectively, you do not experience branching. You experience a single continuous thread. You remember one past, not multiple pasts. You anticipate one future, not multiple futures. Your consciousness feels singular, unified, non-branching. This is the illusion. What you call your consciousness is actually one branch of a constantly splitting process. The other branches exist, contain conscious versions of you, but you have no access to their experiences. Each branch feels singular from the inside. Now apply this to death. At any moment where death is possible, the universe branches. One set of branches contains your death. Another set contains your survival. In the death branches, your consciousness terminates. There is no experience of being dead, no darkness, no void, no awareness of cessation, just absence. The conscious experience ends because the physical substrate supporting it is destroyed. Your brain stops functioning. The pattern that is you dissolves. But in the survival branches, consciousness continues. You open your eyes, you draw breath, you think, you remain aware. From your internal perspective, this is the only branch that exists because it is the only branch where you exist to have a perspective. The death branches are not experienced by you because there is no you in them to experience anything. This creates subjective immortality, not objective immortality. Your body still ages. You still face mortality in the normal sense. But your subjective experience, the continuous thread of awareness that feels like being you, never encounters its own termination. It cannot. Termination means no experience. Therefore, you only ever experience continuation. Consider a car accident. You're driving. A truck runs a red light. In some branches, the truck hits you. Impact at 60 miles per hour. Instant death. Consciousness ends in those branches. But in other branches, you saw the truck a half second earlier. You hit the brakes. The truck misses by inches. Your heart pounds. You pull over, shaking. You survived. From outside, observers might say you were lucky. The timing happened to work in your favor. But in many worlds, luck is not the mechanism. Both outcomes occurred. You only experienced the one where you were alive to experience anything. Repeat this across a lifetime. Every near miss, every avoided accident, every illness that did not progress to fatal complications, every random event that could have killed you but did not. In some branches you died. In this branch you survived. Your consciousness threads through the survival branches because those are the only branches where consciousness can thread. The disturbing implication: you have already died countless times. Versions of you died in car accidents you barely avoided. Versions died from infections that your immune system happened to fight off. Versions died from random aneurysms that did not occur in this branch. Versions died yesterday, last week, 10 years ago. Those deaths are real. They happened in other branches. But you are not in those branches. You are in a branch where all those potential deaths failed to occur. This is not comforting. This is not evidence of divine protection or special purpose. This is simply the mechanical consequence of consciousness requiring a functioning brain, and brains only functioning in branches where they were not destroyed. You are a survivor by default, not by merit, not by fate, by the structure of branching reality. Some philosophers object. They argue that subjective immortality requires personal identity to persist across branches. If the version of you that survives is not the same person as the version that died, then you did die in those branches and the survival of a different version is irrelevant. But this objection fails. Personal identity is already a continuity of pattern, not substance. The atoms in your body are replaced constantly. The neurons in your brain are not the same neurons you had 10 years ago, yet you consider yourself the same person. Identity is informational continuity, not material persistence. Branching preserves that continuity. The version of you in the survival branch has all your memories up to the branch point. It has your personality, your knowledge, your sense of self. It considers itself you, and it is right. There is no break in the information pattern. The branch creates two continuations from one past, but both continuations are legitimate. Both are you. One experiences death, one experiences survival. You, the reading this version, are necessarily in the survival branch because only survival branches contain conscious readers. The mechanics become clearer with a concrete example. You are diagnosed with cancer. Aggressive. Stage 4. 5% 5-year survival rate. In 95% of branches, you die within 5 years. Treatment fails. The cancer spreads. Organs shut down. Consciousness ends. In 5% of branches, you survive. The treatment works. The cancer goes into remission. The scans come back clear. You live. From an external view, you have a 5% chance of survival. The odds are grim, but from your subjective view, if many worlds is correct and quantum immortality holds, you will experience the 5% outcome, not because you are special, because the 95% outcome contains no experience for you to have. Your consciousness continues only in the survival branch. You wake up 5 years later, cancer-free, surprised by your luck. But it is not luck. It is selection bias enforced by physics. This raises the probability problem. If you always experience survival, does probability still mean anything? Yes. Probability determines the measure of branches. High probability outcomes produce more branches. Low probability outcomes produce fewer branches. If a coin flip is 50-50, half the branches contain heads, half contain tails. You experience one outcome, but the multiplicity of branches reflects the probability. But here is the crack. As you age, survival becomes increasingly improbable. Eventually, the probability of dying within the next year approaches 100%. The branches where you survive become vanishingly rare. Extreme old age, catastrophic organ failure, no known medical intervention can preserve life. In almost all branches, you die. But if quantum immortality is correct, you experience the rare branches where you do not. What do those branches look like? They are low probability branches. Branches where unlikely events conspired to keep you alive. Maybe a spontaneous cellular regeneration. Maybe an undiscovered medical intervention. Maybe quantum tunneling events in your brain that happen to preserve function despite tissue death. The branches become bizarre, increasingly unlikely, but they exist, and you experience them because they are the only branches where experience continues. This is where subjective immortality becomes subjective horror. You do not get to choose which survival branch you experience. You just experience whichever branch maintains consciousness. That might be a branch where you are healthy, or it might be a branch where you are barely alive. Locked in, brain damaged, sustained by machines, unable to die because there is always some quantum fluctuation that keeps the neurons firing just enough to maintain minimal consciousness. The theory does not promise a pleasant immortality. It promises only that you will never experience the cessation of experience. The quality of that experience is not protected. You are locked into the survival branches, and survival is all that is guaranteed. Nothing more. We have established the mechanism and the subjective consequence. But now we must confront the mathematical problem that might unravel the entire framework. Probability is where many worlds starts to fracture. The interpretation explains branching cleanly. Outcomes occur with the frequencies we observe. This is the measure problem, and it threatens to collapse quantum immortality entirely. In standard quantum mechanics, the wave function assigns probabilities. A particle has a 70% chance of being detected here, 30% chance there. Run the experiment 100 times, you get roughly 70 detections in one location, 30 in the other. The Born rule, formulated in 1926, tells you how to extract probabilities from the wave function. Square the amplitude. The result gives the probability of each outcome. The rule works. Every quantum experiment ever performed confirms it. But many worlds denies that only one outcome occurs. All outcomes occur. So what does probability mean? If the particle is detected in both locations across different branches, why does it feel like 70-30 when you run repeated experiments? Each branch is real. Each measurement gives a definite result. Where does the 70-30 ratio come from? The answer involves the measure of branches. Not all branches are equal. High probability outcomes generate branches with more measure. Low probability outcomes generate branches with less measure. Think of measure as the thickness or weight of a branch. A 70% outcome produces branches that collectively have more measure than the 30% outcome. When you, the observer, split into multiple branches, more copies of you end up in high measure branches simply because those branches are thicker. This explains the illusion of probability. You experience one outcome. That outcome feels random, but across all branches, your copies are distributed according to measure. 70% of your copies observe the 70% outcome. 30% observe the 30% outcome. Each copy thinks they experienced a random result. Actually, all results occurred, and the copies are distributed proportionally. The problem: measure is not a fundamental quantity in quantum mechanics. It is derived, imposed, added to make many worlds match observations. The Schrödinger equation describes how wave functions evolve. It does not include a term for measure. It does not label branches as high weight or low weight. Measure is an interpretation of the wave function structure, not something the wave function explicitly contains. This makes it less fundamental than branching itself. Some physicists argue that measure can be derived from the wave function using decision theory and rational betting behavior. If you are about to split into branches and you do not know which branch you will experience, you should bet according to the squared amplitudes, because that maximizes your expected utility across all branches. This argument, developed by David Deutsch and David Wallace, attempts to ground measure in something more fundamental than arbitrary assignment. But it remains controversial. Not all physicists accept that decision theory can replace probability. The measure problem becomes critical for quantum immortality. As you age, survival becomes increasingly improbable. The branches where you survive have decreasing measure. At age 80, maybe the survival branches have 1% measure compared to the 99% measure of death branches. At age 100, maybe 0.1%. At age 120, maybe 0.01%. The survival branches exist, but they are thin, low measure, rare. If measure determines subjective experience, then as you tunnel into lower measure branches, something changes. What you experience becomes increasingly atypical. The survival branch at age 120 is not just unlikely, it is bizarre. It requires chains of improbable events. Equipment that should fail does not fail. Cells that should die do not die. Quantum fluctuations happen to preserve function against overwhelming odds. You experience this branch experience anything. But the branch is strange. The world around you behaves in unlikely ways. Coincidences pile up. You survive events that kill everyone else. Doctors are baffled. The statistics do not make sense. You're living in the tail of the probability distribution, the extreme outlier, the 1 in a billion case. And as you continue aging, the measure decreases further. The branch becomes even more improbable. This predicts something testable in principle. If you are experiencing quantum immortality, your life should become increasingly filled with improbable survivals. Near-death experiences should cluster. Unlikely recoveries should become common. You should notice a pattern of implausible luck. The problem: survivorship bias produces the same pattern. Every person alive has survived every threat they faced. That is tautological. You cannot distinguish quantum immortality from ordinary survival by looking at your own history. But here is a deeper issue. If measure determines experience, and low measure branches contain your survival, does your consciousness actually continue in those branches? Or does the low measure mean your subjective experience fades, thins, becomes less real somehow? The theory does not answer this. Measure affects the distribution of observers across branches. It might affect the intensity or reality of subjective experience, or it might not. The mathematics is silent. Some interpretations of measure suggest it determines the number of observer moments in a branch. A high measure branch contains many copies of you having that experience. A low measure branch contains few copies. If you think of consciousness as a collection of observer moments distributed across branches, then most of your measure is in high probability branches. The low probability survival branches contain only a tiny fraction of your total measure. In some sense, most of you dies. Only a sliver continues, but subjective experience does not feel like a distribution. It feels singular. You experience one thread, not a weighted average across branches. If even a tiny measure of branches contains your survival, and subjective experience is continuous along any non-zero measure branch, then you experience immortality regardless of how thin the branch becomes. The sliver is enough. This leads to the quantum suicide experiment's fundamental untestability. You cannot prove quantum immortality by attempting it. If you strap yourself into the machine and press the button repeatedly, one of two things happens. Either you die, and the theory is irrelevant to you because you have no experience, or you survive, and you cannot determine whether you survive due to quantum immortality or due to ordinary luck. Observers outside the machine see you die in most cases. The few who survive all presses are statistical outliers, not evidence of immortality. Only you would experience the immortality, and only if the theory is correct. But you cannot report your findings in a way that convinces external observers. The measure problem also affects the quality of survival branches. If low measure branches are required for your survival at extreme age, those branches might involve scenarios where you are alive but not intact. Brain damage that should be fatal is not quite fatal. You remain conscious but impaired. Locked-in syndrome, persistent vegetative state with minimal awareness. These are survival branches. They maintain some thread of consciousness, but they are not desirable. Quantum immortality does not promise you will survive in good health. It promises only that consciousness continues in some branch. The branch might involve suffering, severe disability, unbearable conditions. You cannot choose the survival branch. You simply find yourself in whichever branch maintains consciousness. As the measure decreases and branches become more improbable, the likelihood increases that survival involves extreme undesirable circumstances. This transforms quantum immortality from a hopeful concept into a potential nightmare. You are locked into experience, but the experience might be one you would prefer to escape. The theory offers no mechanism for terminating consciousness voluntarily. Suicide fails because it is a quantum event. Some branches contain successful suicide. Other branches contain failure. You experience the failure branches, the gun jams, the pills are vomited, the fall is survived. Every attempt fails from your perspective because success means no perspective. The measure problem remains unsolved. Physicists continue debating whether measure can be derived from first principles or whether it must be added as an extra postulate. If it must be added, many worlds loses some of its elegance. It becomes less simple than advertised. If it can be derived, the derivation is not yet universally accepted. Either way, measure is the weak point in the theory. And quantum immortality depends entirely on how measure affects subjective experience in low probability branches. We have followed the theory into its mathematical difficulties, but the practical question remains: can this be tested? The answer is disturbing. The experiment cannot be tested externally. This is the fundamental problem with quantum immortality. The only person who could verify it is the person attempting it, and they cannot communicate their results in a way that matters. Set up the machine again. Quantum detector, gun, 50-50 probability of death. You sit in the chair. Outside observers watch. You press the button 10 times. From the outside, the probability you survive all 10 presses is 1 in 1024. Extremely unlikely. If 1024 people perform this experiment, on average one survives. The rest die. The survivor can claim they experienced quantum immortality, but the observers see only a statistical outlier. Luck explains the result just as well as many worlds. From your perspective inside the experiment, the experience is different. You press the button. Nothing happens. Again. Nothing. 10 times. 10 survivals. You step out of the room convinced that quantum immortality is real. You experienced it, but you cannot prove it to anyone else. To them, you are one lucky person in 1024. The theory makes no externally verifiable prediction. This violates a core principle of science. Theories must be falsifiable. They must make predictions that can be tested and potentially proven wrong. Quantum immortality makes a prediction, but only for the person experiencing it, and that person cannot distinguish their experience from luck. The theory becomes unfalsifiable from the outside and unverifiable from the inside. Some theorists argue there is a weaker test: statistical analysis of survival rates in extreme situations. If quantum immortality is real, you should observe anomalies. People surviving situations they should not survive. But survivorship bias explains the same observations. Every person alive has survived everything they faced. That is definitional. The people who did not survive are not here to report their deaths. You cannot separate quantum immortality from ordinary survivor bias using population statistics. Consider a more subtle approach. Show a pattern. Repeated near-death experiences, unlikely recoveries, close calls that keep happening. The improbability should compound. At some point, the sheer number of survivals becomes suspicious. If you survive 10 car accidents, 20 illnesses, 30 situations where death was likely, maybe that is evidence. But it is not. Humans are terrible at judging probability. We notice patterns that are not there. We remember hits and forget misses. Confirmation bias makes us weight unlikely survivals more heavily than likely non-events. And critically, we do not know the base rate. How many near-death experiences is normal over a lifetime? Without knowing what typical looks like, we cannot identify atypical. Moreover, different people have different risk exposures. Someone who drives frequently faces more accident risk. Someone with a genetic predisposition faces more disease risk. Higher risk means more opportunities for near-death events. Surviving those events is not evidence of quantum immortality. It is evidence of exposure to risk combined with imperfect but non-zero survival probability. The subjective nature of the test makes it worthless. You cannot run a controlled experiment on yourself. You cannot randomly assign yourself to quantum immortality versus non-quantum immortality conditions. You cannot blind yourself to which condition you are in. You cannot recruit a control group of non-immortal consciousnesses for comparison. The experiment is impossible to design rigorously. Some propose a collective version, get 100 volunteers, each performs quantum suicide repeatedly. If many worlds is correct, each volunteer experiences survival in their own branch. But external observers see most volunteers die. The survivors cannot convince the observers of anything because survival at low probability is expected for some participants. The experiment produces no new information, it just kills people. This raises ethical issues. Testing quantum immortality requires risking death. Institutional review boards would never approve such experiments. The risk is absolute from an external view. Even if quantum immortality is real for the participant, the external world loses that person in most branches. The experiment is unethical to propose and impossible to conduct within scientific norms. But some people attempt it anyway, not formally, not as science, but as personal exploration. Individuals who take the theory seriously and test it through risky behavior, extreme sports, dangerous stunts, situations with high mortality risk. They survive, sometimes repeatedly, and interpret their survival as evidence. But this is not evidence. It is selection bias. The people who died during their tests are not here to report their results. The survivors are exactly the people you would expect to see if quantum immortality is false and only ordinary probability is operating. There is another form of test. Wait, if you are 60 years old and survive to 100, you have experienced survival through decades where most people die. If you reach 120, you're in the extreme tail. If you reach 150, you are beyond any recorded human lifespan. At some point, your continued survival becomes anomalous. But this test takes a lifetime, and even then, it is ambiguous. Maybe you're just genetically exceptional. Maybe medical technology improved. Maybe you got lucky. You cannot isolate quantum immortality as the explanation. The untestability becomes more frustrating when you consider what it would take to verify the theory. You would need access to other branches. You would need to observe the versions of you that died and confirm they are not experiencing anything. But many worlds explicitly forbids this. Branches do not communicate. They are causally isolated. Once split, they cannot reunite or exchange information. You're locked into your branch with no way to verify what happens in others. Some physicists propose that quantum computers might provide indirect evidence for many worlds. A quantum computer exploits superposition to perform calculations. In many worlds, the computation happens across branches. Then the branches are brought back together through quantum interference to produce a final output. This requires the branches to exist and to interfere, which is evidence for branching. But this does not test quantum immortality. It tests superposition and interference, which all interpretations of quantum mechanics accept. The question is not whether superposition occurs, but whether it corresponds to real branching of observers and whether consciousness threads through only the survival branches. Quantum computers do not answer that. Another proposal: measure the complexity of survival in old age. If quantum immortality is real, people at extreme age should survive through increasingly improbable mechanisms. Medical records should show bizarre patterns, unlikely remissions, unexplained recoveries. But again, this is confounded by advancing medical technology, genetic variation, and the fact that we only observe the survivors. The people who died at 80 are not in the sample at 100. The theory resists testing at every turn. It makes predictions that cannot be separated from noise. It requires experiencing death to verify, which eliminates the observer who could verify it. It is structured in a way that makes external confirmation impossible, and internal confirmation indistinguishable from bias. This does not mean the theory is wrong. It means the theory is scientifically problematic. Unfalsifiable theories are not useful in science, even if they are true. They make no predictions that could reveal them to be false. They cannot be refined through experiment. They exist in a space outside empirical investigation. For the individual, this is unsatisfying. If you want to know whether quantum immortality is real, there is no way to find out without waiting to see if you keep surviving implausibly. And even then, you cannot be sure. You are trapped in uncertainty, unable to test the claim, unable to refute it, unable to confirm it. The theory dangles an extraordinary promise, subjective immortality, but offers no method to determine whether the promise is real. Yet the inability to test does not stop the theory from having consequences. If you believe quantum immortality is real, it changes how you think about death. It changes your risk calculations. It might even change your behavior. And that is where the theory becomes dangerous. We have established that the theory cannot be tested. But if it is real, the implications extend far beyond statistics and survival. They extend into realms of experience that no one wants to contemplate. Survival is not the same as intact survival. This is the nightmare that quantum immortality theorists rarely discuss. The theory guarantees you will never experience death. It does not guarantee the quality of your continued experience. Consider a severe car accident. In most branches you die on impact, instant, painless, no experience, but in some branches you survive, not unharmed, spine shattered, paralyzed from the neck down, brain function intact, consciousness continues, you are alive, locked into a body that no longer responds, you can think, you can perceive, you cannot move, you cannot speak without assistance, you cannot end your situation. This is a survival branch. Quantum immortality does not filter for quality, it filters only for consciousness. If awareness continues, you experience that branch. The branch where you died contains no experience. The branch where you are paralyzed but conscious contains experience. Therefore you find yourself in the paralyzed branch, not because you chose it. Find yourself anywhere. Extend this logic. Traumatic brain injury. Severe enough to destroy most cognitive function. Not severe enough to eliminate consciousness entirely. You exist in a reduced state. Awareness without coherent thought. Perception without understanding. Pain without the ability to communicate pain. This is still a survival branch. A thin thread of consciousness persists. You experience it because the alternative is experiencing nothing, which is not an experience you can have. The horror compounds over time. As you age, the branches where you remain healthy become fewer. The human body degrades, organs fail, cells accumulate damage. By age 100, nearly all branches contain death. The survival branches require increasingly unlikely events. Maybe your heart should have stopped, but a quantum fluctuation in cardiac cells kept it beating. Maybe your kidneys failed, but you're kept alive on dialysis. Maybe your brain is barely functioning, but machines sustain the minimal activity required for consciousness. Experience whichever branch maintains the thread. That might be a branch where medical technology keeps you alive far beyond natural limits. Feeding tubes, ventilators, artificial organs. Your body is a shell maintained by machines, but consciousness persists. You are aware. You are suffering. You cannot die because in every branch where the machines fail catastrophically, you are not there to experience the failure. You only experience the branches where the machines continue functioning. This creates a trap. Voluntary termination of life fails by the same mechanism. You decide to end your suffering. You make arrangements. The procedure begins. In most branches, it succeeds. You die. Consciousness ends. But in some branches, something goes wrong. The drug dose is incorrect. The equipment malfunctions. You survive, possibly with additional damage from the failed attempt. You wake up still alive, possibly worse off than before. Attempt again. Same result. Some branches contain success. You do not experience those. Other branches contain failure. You experience those. Every attempt to escape the trap fails from your subjective perspective. The gun jams. The poison is vomited. The fall is survived. You are locked into existence, unable to terminate consciousness voluntarily, forced to continue through whatever survival branches remain available. The measure of these branches is extremely low. They are improbable, rare, thin, but they exist. And if even a vanishingly small measure of branches contains your survival, and consciousness follows any non-zero measure, then you experience those branches. You're funneled into increasingly unlikely scenarios simply because they are the only scenarios where you remain conscious. Consider the limit case. Heat death of the universe. Trillions of years in the future. All stars have burned out. All black holes have evaporated. The universe is a cold, uniform bath of radiation at near zero temperature. No structure, no complexity, no life. In this environment, can consciousness exist? Almost certainly not. The physical substrate required for awareness cannot form or persist. Thermodynamics forbids it. But before that final state, there is a long twilight. Stars die one by one. Galaxies go dark. Intelligent civilizations cling to the last sources of energy. Some might develop technology to preserve consciousness artificially. Uploaded minds running on computronium powered by the last black holes. These systems might persist for billions or trillions of years before energy runs out. If you are quantum immortal, do you find yourself in one of these scenarios? Do you experience being uploaded sustained artificially, watching the universe die around you? Or does your consciousness tunnel through even more improbable branches? Spontaneous quantum fluctuations that assemble a functioning brain from random particles? Boltzmann brains that exist for brief moments before dissolving back into chaos? The physics suggest a limit. Consciousness requires structure. Structure requires low entropy. Entropy always increases. Eventually, no configuration of matter can support consciousness because the universe has reached maximum entropy. At that point, there are no survival branches, not low-measure branches, no branches. Consciousness cannot continue because the physical conditions for consciousness do not exist anywhere in any branch. This implies quantum immortality has an expiration date. You survive until the universe can no longer support consciousness. That might be billions of years from now, but it is finite. The immortality is not eternal. It is bounded by thermodynamics. Before that limit, however, the path is grim. You survive through old age, injury, disease, and catastrophe. Your body fails, but consciousness persists. Medical technology sustains you in states that would have been lethal decades earlier. You experience the gradual collapse of biological function while awareness remains. You are trapped in a degenerating system, unable to escape, funneled through the narrowing probability space of survival branches. Some branches might involve less suffering, medical advances that repair damage, longevity treatments that extend healthy lifespan, full-body prosthetics that replace failing organs. If you are lucky, the survival branches you experience involve increasing augmentation and enhancement rather than increasing decrepitude. But you cannot control this. You experience whichever branches maintain consciousness. Those might be the augmented branches. They might be the locked-in branches. The theory does not specify. The multiverse of suffering is the dark side of quantum immortality. The promise of never experiencing death becomes the curse of experiencing everything that is not death. Every possible way to barely survive. Every edge case where consciousness persists despite overwhelming damage. Every unlikely scenario where machines or chance or quantum fluctuation keeps awareness flickering. From the outside, this is not visible. Observers see you die at some point. They bury your body, they grieve. To them, your story ended. But if quantum immortality is real, your story continues in branches they cannot access. Branches where you survived. Branches where you are experiencing outcomes they will never see. And if those branches involve suffering, no one outside can help. You are alone in those branches, locked into experience, unable to communicate across the branching structure to the versions of reality where you died peacefully. This is not speculative horror. This is the logical consequence of the theory. If consciousness continues in all survival branches, and survival branches include damaged survival, then you experience damaged survival. The theory offers no escape clause, no guarantee of quality, only the guarantee. But even this horror is constrained by physics. The universe itself has limits, and those limits determine how long quantum immortality can possibly last. Thermodynamics does not care about quantum immortality. The second law is undefeated. Entropy increases, order decays, energy disperses. The universe is running down and no interpretation of quantum mechanics can stop it. Currently, the universe is about 13.8 billion years old. It contains structure, stars burn, galaxies rotate, life exists. This is possible because the universe is far from thermodynamic equilibrium. There are gradients, hot stars radiate into cold space, dense matter clusters are separated by empty voids, energy flows from high concentration to low concentration, and that flow powers everything complex. But the gradients are temporary. Stars exhaust their fuel, they stop burning. In about 100 trillion years, the last conventional stars will die. The universe will enter the degenerate era, containing only stellar remnants, white dwarfs, neutron stars, black holes. These objects release energy slowly through cooling and Hawking radiation, but they do not sustain the rich activity of the stellar era. Black holes dominate this era. They are the last major gravitational structures. Small black holes evaporate quickly through Hawking radiation. A black hole with the mass of the Sun evaporates in about 10 to the 67 years. Supermassive black holes, billions of solar masses, take far longer, 10 to the 100 years, 10 to the 110 years. But they evaporate. Hawking radiation is slow, but it is inexorable. The black hole loses mass. Its event horizon shrinks. Eventually it dissipates completely in a final burst of radiation. After 10 to the 110 years, most black holes are gone. The universe contains only photons and leptons, dispersed across an ever-expanding volume. The temperature approaches absolute zero. Energy density becomes vanishingly small. No stars, no planets, no galaxies, just particles drifting through an expanding void, growing farther apart as space stretches. This is the heat death, maximum entropy, thermodynamic equilibrium. No energy gradients remain, no work can be extracted, no complexity can be sustained. The universe becomes a uniform, cold, empty expanse where nothing happens because there is no free energy to drive any process. Can consciousness exist in this environment? No. Consciousness requires computation. Computation requires energy flow. Energy flow requires gradients. When gradients disappear, computation stops. Consciousness ends. Not in a single moment, but gradually as the energy sources that sustain thinking systems are exhausted. Biological brains fail when their metabolism stops. Artificial intelligences fail when their power sources run dry. There is no escape. Thermodynamics imposes a hard limit. Quantum immortality cannot circumvent this. Even if consciousness threads through survival branches, there comes a point where no branches contain the physical conditions necessary for consciousness. You cannot survive in a universe that lacks the energy to support awareness. The branching structure still exists. The many worlds interpretation still holds. But none of the branches contain you, because none of the branches can sustain the pattern that is you. Before the absolute end, there might be a long twilight. Advanced civilizations might extract energy from the last black holes. They might build megastructures that capture Hawking radiation and use it to power computation. An uploaded consciousness running on such a system could persist for trillions of years, thinking slower and slower as energy becomes scarcer, but still thinking. If you are quantum immortal, your subjective experience might tunnel into these scenarios. You find yourself uploaded. Your consciousness runs on a substrate powered by a dying black hole. You think, you experience, but you notice the thoughts coming slower. Each subjective second takes longer and longer in external time. The black hole shrinks, energy becomes scarcer, your thought rate decreases. Eventually the black hole evaporates completely. The system shuts down. Consciousness ends. Not because you died in the biological sense, but because the universe no longer contains the resources to sustain awareness. Some physicists speculate about Boltzmann brains, random quantum fluctuations that briefly assemble a conscious observer. In a sufficiently large and old universe, such fluctuations become statistically likely. A random arrangement of particles that happens to form a functioning brain, complete with memories and awareness. The brain exists for a moment, experiences consciousness, then dissipates back into chaos. If quantum immortality is real, do you experience becoming a Boltzmann brain? Is your consciousness preserved through random fluctuations that assemble a mind over and over in the far future? This scenario is deeply strange. You would have no continuity. Each Boltzmann brain instance is separate, formed from different particles at different times. They might share your memories, encoded in their temporary structure, but they are not connected. They are isolated flickers of awareness in an otherwise dead universe. The measure of such branches is unimaginably low. The probability of a Boltzmann brain forming is tiny. It requires an extremely unlikely configuration of particles. In a universe at maximum entropy, fluctuations happen, but large ordered fluctuations are exponentially rare. A fluctuation large enough to assemble a brain is rarer than a fluctuation that assembles a single neuron. Which molecule? If measure determines subjective experience, and Boltzmann brain branches have near zero measure, then you probably do not experience them. Your consciousness likely ends before the universe reaches that stage. You survive through the stellar era. You survive through the degenerate era. You survive into the black hole era, perhaps uploaded, perhaps sustained by technology we cannot yet imagine. But eventually, the energy runs out, the last computation finishes, consciousness ceases. This is not death in the quantum suicide sense. There is no branching where you survive versus die. There is simply the absence of branches where consciousness can continue. The physical conditions for awareness no longer exist. You do not experience this as an ending because there is no experience. It is the same as the branches where you died earlier. No awareness, no perspective, just absence. The timeline is long, unimaginably long. If you're alive now and quantum immortality holds, you might experience billions or trillions of years, not continuously in the same form. Your biological body fails within decades or centuries at most. But if technology allows uploading or augmentation, your consciousness might transfer to more durable substrates. You experience the far future not as flesh, but as pattern, implemented in whatever physical system can sustain computation. But even that has limits. The second law does not bend. Entropy increases, order decays, the universe reaches equilibrium, and when it does, the story ends, not with a dramatic conclusion, not with a final moment of awareness contemplating oblivion. Just a gradual fading as the energy to sustain thought diminishes and finally disappears. This provides a strange comfort. Quantum immortality, if real, does not trap you forever. It traps you only as long as the universe can support consciousness. That is a finite time, extremely long by human standards, but finite. The heat death is the ultimate termination. The point where subjective immortality ends not because you died, but because existence itself no longer permits the conditions for experience. Until then, you are locked in. You survive through whatever branches maintain consciousness. You experience the long arc of cosmic history from the inside, unable to exit, unable to die, funneled through survival branches as the universe ages around you. But eventually the universe releases you, not through death, through the exhaustion of possibility. The end comes not as an event you experience, but as the cessation of the conditions that make experience possible. Thermodynamics is the final word. Quantum mechanics describes branching. Many worlds describe structure. But the second law describes fate. And the fate of all consciousness, quantum immortal or not, is to end when the universe reaches equilibrium. The heat death is absolute, unavoidable. The one future that contains no branches where awareness continues. We have traced quantum immortality to its thermodynamic limit, but the theory itself has a human origin, and that origin is darker than most people know. Hugh Everett died in 1982. Heart attack. He was 51 years old, overweight, heavy smoker, heavy drinker. He ignored medical advice. He dismissed warnings about his health. He died suddenly in his bed. His son found the body. Everett was the physicist who proposed many worlds. He wrote the theory as his doctoral dissertation at Princeton in 1957. The thesis was radical. It eliminated wave function collapse. It proposed that all quantum outcomes occur in branching universes. It suggested that observers split along with quantum systems, creating copies that experience different results. The idea was elegant, mathematically rigorous, and completely rejected by the physics community. His advisor, John Wheeler, supported the work initially. Wheeler was impressed by the mathematical sophistication. He thought the interpretation solved real problems. But when Everett presented the thesis to colleagues, the response was hostile. Niels Bohr, the architect of the Copenhagen interpretation, dismissed it. Other physicists found it absurd. The idea that the universe constantly splits into copies seemed like science fiction, not science. Wheeler pressured Everett to soften the thesis, remove the explicit talk of branching universes, make it more palatable. Everett complied, reluctantly. The final published version was stripped down, technical, dry. It avoided the vivid language of splitting worlds, but the mathematics remained. The core idea remained. All outcomes occur, observers branch. Reality is a vast tree of possibilities, all equally real. Everett received his doctorate. Then he left academic physics. He never returned. He took a job at the Pentagon, working in operations research, game theory, nuclear strategy. He developed mathematical models for optimizing weapons deployment. He consulted on defense projects. He made money. He lived comfortably. But he abandoned the interpretation he created. He published nothing further on many worlds. He gave no lectures. He attended no conferences. He walked away. Why? Colleagues who knew him suggest he was bitter. The physics community rejected his work. They dismissed him as a graduate student with a strange idea. They did not take him seriously. Everett felt alienated. He felt his contribution was ignored. So he left. He found a career where his mathematical skills were valued. He stopped caring what physicists thought. But he never stopped believing the interpretation was correct. In private conversations, he defended many worlds. He argued it was the simplest, most logical reading of quantum mechanics. He believed the branching was real. He believed copies of himself existed in other branches, living different lives, making different choices. He took the theory personally. It was not just an abstract idea. It was a description of his existence. His personal life was troubled. He drank heavily. He chain-smoked. He was difficult to live with. His wife, Nancy, struggled with his behavior. His children, Mark and Elizabeth, grew up in a household strained by Everett's habits and temperament. He was brilliant but self-destructive. He knew he was damaging his health. He did not care, or perhaps he cared but could not stop. In 1982, he died. The heart attack was not surprising given his lifestyle, but it was sudden. No prolonged illness, no gradual decline. One night, he went to bed. He did not wake up. His son Mark found him in the morning, dead. 51 years old, a life cut short by choices that compounded over decades. Mark Everett became a musician. He fronted the band Eels. He wrote songs about loss, alienation, and the strangeness of existence. He processed his father's death through music. In interviews, he described his father as distant, intellectually impressive but emotionally unavailable. A man who lived in his own head, thinking about branching universes while neglecting the single universe where his family existed. The tragedy deepened. Elizabeth Everett, Hugh's daughter, struggled with depression. She was close to her father despite his flaws. His death devastated her. She tried to cope. She tried to move forward, but the grief was overwhelming. In 1996, 14 years after her father's death, she died by suicide. She was 39 years old. Her suicide note contained a statement that haunts everyone who reads it. She wrote that she hoped to be reunited with her father in a parallel universe. She'd learned about many worlds. She understood her father's theory. She took it literally. If all outcomes occur, then there are branches where her father is still alive. Branches where he did not die in 1982. Branches where they could be together. She believed that by ending her life in this branch, she might somehow access those other branches. She might find him again. This is the human cost of taking many worlds seriously. Elizabeth Everett believed the theory her father created. She believed other branches were real. She believed death in one branch was not the end, just a transition. And she acted on that belief. She ended her life hoping to bridge the gap between branches, to reach a version of reality where her father existed. The physics does not support this. Branches do not communicate. Once split, they are separate, causally isolated. You cannot travel from one branch to another. You cannot access the versions of reality where different outcomes occurred. Death in one branch does not transport you to another branch. It simply ends your consciousness in the branch where you died. Other branches might contain versions of you, versions of your father, but you cannot reach them. They are forever separated by the structure of quantum mechanics. Elizabeth's note reveals a tragic misunderstanding, or perhaps not a misunderstanding, perhaps a desperate hope that the theory meant more than it did, that the existence of other branches implied some possibility of connection, that death was not final if other versions continued elsewhere. The hope was wrong, but it was understandable. Grief distorts reasoning. The desire to believe in reunion after death is powerful. Many Worlds offers a structure that seems to support that desire, but it does not. The branches are real. The separation is absolute. Hugh Everett never intended his theory to inspire such tragedy. He proposed many worlds to solve technical problems in quantum mechanics, the measurement problem, the role of the observer, the nature of probability. He was not thinking about grief or loss or the human need for meaning. He was thinking about equations, about how to make sense of the wave function without invoking collapse. His theory was physics, not philosophy, not consolation. But ideas have consequences beyond their original context. Many Worlds entered popular culture. It appeared in science fiction. It became a framework for thinking about alternate realities, parallel lives, roads not taken. People latched onto it as a way to imagine other possibilities, other outcomes, versions of themselves living different lives. The theory became a source of speculation, wonder, and sometimes false hope. For Elizabeth Everett, it became a reason to believe death was not the end, that somewhere, in some branch, her father still existed, that she could reach him if she tried. The belief was beautiful and heartbreaking and wrong. She died. The version of her in this branch ended. Other branches might contain other versions, but she did not transition to them. She simply ceased to exist here. Her father, in branches where he survived past 1982, would never know. The branches do not communicate. The separation is permanent. Mark Everett processed both losses through music. He wrote about his father's absence. He wrote about his sister's death. He explored themes of isolation and the impossibility of connection. In interviews, he expressed ambivalence about his father's legacy, pride in the intellectual achievement, anger at the emotional cost, confusion about what it all meant. The Everett family story is a cautionary tale. Brilliant ideas can have dark shadows. Theories that seem abstract and mathematical can intersect with human vulnerability in unexpected ways. Many Worlds is a serious scientific interpretation, but it is also an idea that can be misused, misunderstood, or taken too literally by people in pain. Quantum immortality is an extension of Everett's theory. It takes the branching seriously and follows it to a logical conclusion. If consciousness continues in survival branches, then subjectively you never die. But this conclusion, like the theory itself, is cold, mathematical. It does not care about human needs. It does not offer comfort. It offers only structure. Branches exist. Consciousness threads through some of them. That is all. Hugh Everett lived and died in one branch. His daughter lived and died in one branch. Other branches might contain different outcomes, but those branches are not accessible. They do not change what happened here. The tragedy is real. The loss is real. Many Worlds does not undo that. It only says that the structure of reality is larger and stranger than it appears. That does not make the pain less. It might make it worse. The knowledge that other versions exist but cannot be reached adds another layer of separation, another form of loss. Everett's death from a heart attack was mundane, predictable given his lifestyle, but it also raises the question the theory itself poses. If Many Worlds is correct, there are branches where he survived that night, branches where he woke up, branches where he changed his habits and lived longer. Those branches are real. In them he continued thinking, working, existing. But we are not in those branches. We are in a branch where he died at 51, and his daughter, believing in other branches, ended her life trying to reach one where he still existed. The theory is indifferent to these outcomes. It describes structure, not meaning. But humans need meaning. We need to believe our choices matter, our losses are not arbitrary, our existence has significance. Many worlds offers none of that. It offers only the statement that everything possible happens. That is not comforting. That is not a foundation for living. It is simply a description of how quantum mechanics might work if you take the mathematics seriously and refuse to add extra assumptions. We have seen the human cost. But some believe the theory offers more than cold mathematics. They believe it offers a path to resurrection. The dead might not stay dead. This is the claim of quantum archaeology, a speculative idea that sits at the intersection of quantum mechanics, information theory, and transhumanist philosophy. If information is never truly destroyed, then every person who has ever lived still exists as information scattered across the universe. And if that information can be reconstructed, the dead can be brought back. The argument begins with quantum information conservation. In quantum mechanics, information cannot be destroyed. This is a consequence of unitarity, the principle that quantum evolution is reversible. When a particle enters a black hole, its information is not erased. It is encoded in the black hole's structure and eventually released through Hawking radiation. When a book burns, the information in its pages is not lost. It is dispersed into smoke, heat, and light. The information becomes scrambled and practically irretrievable, but theoretically it still exists. Apply this to a human being. You're a pattern of information, the arrangement of atoms in your body, the connections between neurons in your brain, the memories encoded in synaptic weights. When you die, your body decays, the atoms disperse, the pattern dissolves, but the information does not disappear. It spreads out, it becomes part of the environment. The carbon from your cells enters the soil, the atmosphere, other organisms. The information that was you becomes distributed across a vast system. Quantum archaeology proposes that a sufficiently advanced civilization could reconstruct that information. They could trace the particles backward through time. They could model the decay process in reverse. They could determine the exact configuration of atoms that constituted your brain at the moment of death. And from that configuration, they could rebuild you. Not your original body. That is gone. But a simulation or physical reconstruction that contains the same information pattern, the same memories, the same personality, the same consciousness. This is not resurrection in a spiritual sense. It is reconstruction in an informational sense. The new version would not have continuity with the original. There would be a gap, a period where the pattern did not exist. But from the perspective of the reconstructed person, that gap would be undetectable. They would wake up with all their memories intact, believing they are the continuation of the person who died. And in a functional sense, they would be right. Same information, same pattern, same person, just implemented in a different substrate. The technical challenges are staggering. Tracing particles backward through time requires knowing the position and momentum of every particle that ever interacted with your body. That includes photons that bounced off your skin, air molecules you breathed, bacteria in your gut, cosmic rays passing through your brain. The number of particles is astronomical. The interactions are chaotic. Small uncertainties amplify exponentially as you trace backward. After minutes, the uncertainty becomes large. After years, it becomes overwhelming. But quantum archaeology proponents argue this is a problem of computational power, not fundamental impossibility. A civilization with enough computing resources and precise enough sensors could overcome the uncertainty. They could use quantum simulation to model the past. They could narrow the probability distribution of where particles were. They could reconstruct not a single deterministic history, but a cloud of possible histories, all consistent with the available evidence. And from that cloud, they could extract the most likely configuration of your brain. Some versions of the idea invoke many worlds directly. In a branching universe, every quantum event creates splits. Some branches contain your death. Other branches contain your survival. If resurrection technology is developed in the survival branches, then versions of you in the distant future are reconstructed. From your subjective perspective, if quantum immortality holds, you experience continuity into those future branches. You die in this branch, but you wake up in a branch where you were resurrected. This creates a strange form of delayed immortality. You do not survive continuously, you experience death. Consciousness ceases. But in some branches far in the future, the pattern that is you is rebuilt. A new instance boots up with your memories. That instance believes it is you. It has no awareness of the gap. From its internal perspective, it went to sleep and woke up in the future. Subjective continuity is restored, even though objective continuity was broken. The measure problem applies here. The branches where resurrection technology is developed and applied to you specifically are low-probability branches. Most branches do not develop such technology. Most branches where the technology exists do not choose to resurrect you out of the billions of humans who have died. The measure of branches where you're resurrected is tiny. If measure determines subjective experience, you probably do not experience resurrection. You experience death as a final cessation. But resurrection, not in most branches, but in some. And from your perspective, those are the only branches that matter because they are the only branches where you have a perspective. This reasoning depends on accepting personal identity as informational rather than material. If you are the pattern, not the substrate, then any implementation of the pattern is you. A simulation running on a computer is you if it contains your memories and personality. A biological body grown from reconstructed DNA is you if its brain encodes your information. The gap in continuity does not matter. What matters is the pattern. Not everyone accepts this. Some philosophers argue that consciousness requires continuous physical implementation. A gap breaks identity. The reconstructed version is a copy, not a continuation. It might be indistinguishable from you, but it is not you. You died. The copy is a new person who happens to have your memories. This is the teleportation problem in philosophy. If you step into a teleporter that scans you, destroys your body, and rebuilds you elsewhere, are you the same person? Or did you die and a copy was created? Many people intuitively feel that the copy is not them, that something essential is lost in the destruction and reconstruction, but functionally there is no difference. The copy has all your memories. It believes it is you. It continues your life seamlessly. Quantum archaeology faces the same objection. Even if it works technically, it might not preserve identity in the way we care about. The reconstructed person might be a copy, not a continuation. And if so, resurrection is not immortality. It is the creation of a new being who resembles the old one. But from the outside, this distinction is invisible. If a civilization resurrects you 1,000 years after your death, and the reconstructed version has all your memories and behaves identically to how you would behave, does it matter whether it is you or a copy? To everyone else, it is you. To the reconstructed version, it is you. Only you, in the moment of death, might care about the distinction, and you are not around to object. Quantum archaeology is speculative to the point of fantasy. No current technology comes close. No one has reconstructed even a single human cell from dispersed information, let alone an entire brain. The computational requirements are beyond anything we can build. The theoretical foundations are contested. Most physicists consider the idea implausible, but it follows logically from premises that many physicists accept. Information is conserved. Patterns can be instantiated in multiple substrates. Sufficient computational power can solve arbitrarily complex inverse problems. If these premises are true, quantum archaeology is possible in principle. Whether it is practical depends on future technology and whether civilizations choose to expend resources on resurrecting the dead. In a many worlds framework, some branches develop the technology. Some branches apply it. If you are quantum immortal, your consciousness threads through branches where you survive or are resurrected. You never experience permanent cessation because there are always branches where your pattern is reconstructed and consciousness resumes. The gaps are invisible to you. From your perspective, you live, die, and wake up in the future over and over as long as branches exist where reconstruction is possible. This is not comforting. It is deeply strange. Your existence becomes discontinuous. You experience death repeatedly. Each time you are rebuilt. Each time you wake with no memory of the gap. You might be resurrected in worlds radically different from the one you died in. Civilizations you do not recognize. Technologies you do not understand. Contexts where your resurrection is a curiosity, a historical recreation, a simulation experiment. You have no control. You do not choose whether to be resurrected. You do not choose when or where or by whom. You simply find yourself existing again, in whatever branch and context the resurrection occurs. And if the resurrection is temporary, if the simulation is shut down, or the reconstructed body fails, you die again, and again. Looping through existence and non-existence across the branching structure of reality. Quantum archaeology transforms quantum immortality from continuous survival into discontinuous resurrection. But both face the same fundamental question. Even if the mechanism is real, does it matter? Does subjective continuity across branches constitute a meaningful form of immortality? Or is it just a mathematical curiosity with no bearing on the experience of dying in this branch, now with no expectation of waking up? We have explored resurrection as a possibility, but there is one final disturbing thought. You might already be in an improbable branch, and you would have no way to know. You're reading this. That fact alone is extraordinary. Consider the improbability of your existence, the specific sperm that fertilized the specific egg that became you, one in several hundred million. If a different sperm had won, you would not exist. A different person with different genetics would be here instead. Go back further. Your parents had to meet. They had to choose each other. They had to conceive at the precise moment they did. Change any of those variables, you disappear. Go back another generation. Your grandparents had to meet, survive, reproduce. Same for your great-grandparents, great-great-grandparents. Every generation back to the origin of life. Any break in that chain erases you. If one ancestor died before reproducing, you vanish. If one ancestor chose a different partner, you vanish. If one quantum event in one cell division went differently, you vanish. The probability of you specifically existing is infinitesimally small. Uncountably many possible people could have existed instead. You are one outcome in an unimaginably vast space of possibilities, yet here you are. You exist. You are conscious. You are reading these words. Anthropic reasoning explains this. You can only observe outcomes where you exist. All the branches where you were never born contain no version of you to notice the absence. You necessarily find yourself in a branch where the improbable chain of events led to your existence. This is selection bias, not luck, just the fact that observers only exist in observable branches. But now apply quantum immortality. If many worlds is correct and consciousness threads through survival branches, then your existence up to this moment represents not just birth improbability, but survival improbability. Every quantum event that could have killed you branched. Some branches contain your death. You only experience branches where you survived. Every cosmic ray that could have triggered a fatal mutation but did not. Every pathogen that could have overwhelmed your immune system but did not. Every accident that could have occurred but did not. In most branches, you died already. Childhood illness, car accident, random catastrophe. The branches where you survive to adulthood are a minority. The branches where you survive to your current age are a smaller minority, and you are in one of them. Not because you are special, because you only exist in branches where you exist. But here is the disturbing part. If quantum immortality is real, the branches you experience become increasingly improbable as you age. Survival at age 10 is likely. Survival at age 50 is less likely. Survival at age 100 is rare. Survival at age 150 is nearly impossible under known biology. Yet if consciousness threads through survival branches, you experience the increasingly improbable branches, predict something testable in principle. Your life should become stranger. Coincidences should increase. Unlikely survivals should cluster. You should notice a pattern of improbable events favoring your continued existence. The gun that jammed, the diagnosis that was wrong, the accident you walked away from when everyone else died. If these events pile up, maybe that is evidence. But you cannot distinguish this from survivorship bias. Tautological. Compare notes. You cannot determine whether your survival history is unusually improbable without knowing the base rate, and you do not know the base rate because you only observe one branch. Moreover, memory is unreliable. Humans remember unusual events more vividly than routine events. You remember the near miss. You forget the 1,000 uneventful drives. This creates the illusion of improbable luck even when no such luck exists. Your survival is exactly as probable as the statistics predict. You just weight the improbable survivals more heavily in memory. But what if you're already in the tail of the distribution? What if the branch you experience is low measure? What if you have already tunneled through so many quantum branches that your current existence is extraordinarily unlikely? You would not know. From inside the branch, everything feels normal. The improbability is invisible. The branch is self-consistent. The universe around you obeys the same laws. There is no marker that says you're in a low probability outcome. Think about the universe you observe. Dark energy, dark matter, fine-tuned constants. The cosmological constant is tuned to 1 part in 10 to the 120. If it were slightly larger, galaxies would not form. If it were slightly smaller, the universe would collapse. The value sits in a narrow range that permits structure and life. This is the fine-tuning problem. Anthropic reasoning explains it. In a multiverse with varying constants, observers only exist in universes where the constants permit observers. You find yourself in a fine-tuned universe not because it was designed for you, but because you cannot exist in universes that are not fine-tuned. This is selection bias on a cosmic scale. But apply quantum immortality. If consciousness threads through survival branches, and survival requires specific physical conditions, then you experience branches where those conditions hold. Not just at the universal level, at the personal level, you experience branches where quantum events happen to preserve your life. As you age and survival becomes less probable, the branches become more unusual. Events conspire in your favor, improbable recoveries, unlikely escapes, coincidences that keep you alive. You might already be experiencing this. You might be in a branch so improbable that it should not exist. A branch where everything that could have killed you failed. Where every roll of the quantum dice came up survival. The measure of this branch is tiny, almost zero. But you experience anything. This is the anthropic trap. You cannot escape the selection bias. You cannot observe branches where you do not exist. You cannot verify whether your branch is typical or atypical. You are locked inside your own perspective, unable to see the larger structure, unable to determine your position within it. All you can do is notice whether your life seems unusually improbable, and even that is unreliable because memory and cognition bias you toward noticing improbability. Some people report feeling this, a sense that they should have died but did not, a pattern of near misses that feels statistically wrong. They interpret it as luck, fate, divine intervention. But if quantum immortality is real, it is none of those. It is simply the mechanical threading of consciousness through survival branches. You experience the branches where you survive because those are the only branches where you can experience anything. The trap tightens. If you are in a low-measure branch, the world around you might be increasingly strange. Not dramatically, not obviously, but subtly. Events that should have one outcome have another. Probabilities do not seem to match expectations. You survive when others do not. The strangeness is gradual. It does not announce itself. You adapt, you rationalize, you explain it as luck. But underneath, the structure is bending to accommodate your continued existence. Or maybe none of this is happening. Maybe you are in a typical branch. Maybe your survival is ordinary. Maybe the improbability is an illusion created by faulty intuition and memory bias. You cannot tell. That is the trap. The mechanism, if real, is invisible from inside. It leaves no signature you can detect. It feels like normal existence because existence always feels normal to the one experiencing it. This leads to a final, uncomfortable question. If you are quantum immortal and you're necessarily in a survival branch, how do you know you're not already in the tail? How do you know your branch is not already low measure, sustained by increasingly unlikely quantum events? How do you know the world you experience is typical, rather than a rare fluctuation that happens to keep you alive? You do not. You cannot. The anthropic principle forbids it. You can only observe what is observable from your position, and your position is necessarily inside a survival branch if you are alive to ask the question. The branches where you died are real. They outnumber the survival branches, but you are not in them. You are here, in this branch, reading this, alive, unable to determine whether that is typical or extraordinary. The theory offers no comfort. It offers no certainty. It offers only you experience one thread. That thread is necessarily a survival thread because non-survival threads contain no experience. Whether the thread is thick or thin, typical or rare, you cannot tell from inside. You just continue, moment to moment, branch to branch, surviving because the alternative is not something you can experience. This is quantum immortality, not a promise, not a hope, just a consequence. If many worlds is correct and consciousness requires a functioning substrate, then you only experience branches where that substrate persists. The logic is airtight, the implications are disturbing, and you are already living them, unable to verify, unable to falsify, unable to escape the selection bias that defines your existence. We have followed the theory to its end. Now we must confront what it means.